So the problem statement for today's stock span problem. I won't explain the solution and all this. Like you, there are better videos for that. But what I'll explain a shorter method, like how you can work on indexes instead of working on values. So for detailed solution, how these things are done, what are indices, and why I am finding my nearest greater left basically. So you must watch Sumit sir's video, which I have referred to, and there you can get an idea. I'll just explain this basic code to myself only. So the thing is, we have declared a vector and stack. Okay, basic vector and stack. What stack will do? Stack will keep a track of these left values. What vector will do? This is our answer. Basically, I'll just push my values into my vector. This is my answer vector. So there are three conditions. I'll explain them here. So what we learned in stock span problem is that how we can work on indexes instead of working on values while using stack. For example, in previous videos, in previous questions, what we were doing, we were working on values, for example, on these values. But instead of working on these values, we'll learn how we can basically work on indexes, because this is very important and you'll see the importance here. So there are three rules basically. Traverse from left to right, then check top of stack. Okay, check top of stack, and there from there you can go two ways. For example, what I'm doing is I'm just checking my stack top with some value, against some value. I'll just explain what is it. I'm just checking, this is my first way and this is my second way which I can go. So basically, first way is like you can or you cannot skip it. You can either skip it or you cannot skip it. But second way you cannot skip. So first way can be skipped, and I'll tell you how. So there are two ways. One way is if you like basically I am on this value, okay, I'm starting from 100. So we'll just assume that there is no greater values in left of 100. So what I'll do, there are these values, so there are no greater values in left of 100, so the span will be 1. And how span is calculated, I'll just give a fresh a quick brief. For example, if you are calculating for this value, so you have to find the nearest greater left, like whichever value is greater in left. For example, this is greater, so you just have to subtract the indexes. Basically it's 1. For example, for 85 the nearest greater value is 100, so my span will be 6 minus 0, basically 6. So you can see the solution also. For this it will be 6. So uh, yeah, so what I'm doing for this, there is nothing on left, so I'll just enter 0 in my stack and I'll just enter 1 in my stock span. Now from this value will be checked against these values like the previous values, and I'll check it against this 100, that if it's greater, there can be two ways. If you are greater, basically you are standing on this value, if you are greater than your previous value, or if your previous value is greater, there can be only two ways. Okay, so if you are greater than your previous values, for example this value, this thing, if you are greater than your previous value, what we'll do, you'll pop from stack. You'll get an idea why we are popping and what a stack is basically and how we are filling it. So just keep in mind, if we are greater, we'll keep popping until we arrive on this thing. What is this thing? Until the previous element not previous, basically until the top of stack is greater. For example, I have pushed, just a second. For example, I have pushed these many elements. Okay, 100, 80, and 70, then 75. Okay, and we are standing on this element. Now this element wants to find that if the top of stack is greater, this thing, if the top of stack is greater than me or not. No, it is not greater. So what we'll do, if you are greater, basically we are satisfying this condition. If you are greater, then we'll keep popping until we arrives on this condition. What this condition is, that until we find a greater element than ourselves. Just remember, we are 85 and we want to find greater element. So what we'll do, we'll pop this value, we'll check against this, we'll pop this also, we'll pop this also, and we'll end up coming on 100. So basically we'll keep popping. So that's what this loop is doing. That's what this loop is doing. And very important thing, one more very important thing, we are playing on values. We are not playing on we are playing on indexes, sorry, we are playing on indexes, we are not playing on values. So we will not store 100, we will not store 80, 60 in our stack, but instead what we'll store the index of this. For example, if I want to find where my 100 is, what I can store, in my array I can just store 0. So whenever I'll call array of 0, my 100 will pop out. For example, if I want to here only, if I want to find where my 60 is, leave 60, 70, 75, where my 75 is, what I'll do, I'll just store my value as 5, and whenever I'll call my array of 5, it will provide me with 75. Then there is no need, there is no need to store these value, we are just saving our spaces. You'll get to know, you'll get an idea. Okay, so that was our checking basically. So first check is done there. If the previous value is small, we'll just pop, that's it. That's the condition. If previous value is small, we'll pop. So let's start traversing. Okay, so on 80, previous value is not small, so will not pop. If will not pop, what we'll do, we'll find our answer basically. This whole question is finding nearest greater left. So I just need to find the nearest value which is greater than me on my left. So if I'm standing on 80, I need to find nearest value on my left which is greater than me, which is 100 only. You'll get an idea, just stick with me. So now, and how stocks are found? Indexes. Subtract the indexes. 1 minus 0 is 1 only basically. So my answer will be, this is also 1. This is just remember that this is my answer array. This is my answer array or vector, whatever you are filling with. So okay, and in stack now the important thing is, ignore this, just remember that after traversing this, we have traversed this value, now we will move on to next value. So after traversing it, what we'll do, we'll push this value into our stack. So our stack, oh, just blunder, just a second. We will not push the value, we'll push the indexes basically. That was a huge blunder. We'll push indexes. That's the whole point of this video, that we are training our indexes. So instead of pushing 80, what I'll do, I'll push it index. So in my stack, this will be my new value. Okay, now we are currently standing on 60. On 60 again, the same check will be performed, this check will be performed. If the leftmost value is smaller, is it smaller? No, it is not smaller. So what we'll do, we'll come into this. Just see this, we are standing here and we are checking if the leftmost value, what is the leftmost value? Leftmost value is the top of stack. Just give me a second. This is my stack. Okay, I have filled it with 0 and I have filled it with 1. Now my array of I is currently 60, and I want to check the previous value, basically the top of array, the top of stack, sorry. So how will I check? I'll just call these value, I'll just call s top. This will return s top. S top will be, this value will be 1. So I'll be returned with array of 1. What will be the value of array of 1? Array of 1 is 80. So basically the whole formula for checking, the whole formula for checking if our value is greater or smaller will be array of I, which is 60. I'll just write here also, which is 60. Array of I greater than or equals to array of s dot top. S dot top, this top will be equals to 1, and this whole value will be equals to 80 in our case. So this condition is false, basically 60 is not greater than 80. So if this condition is false, we'll come here that top is greater than you. If top is greater than you, then find the difference in your indexes, and that's your answer. So your index is currently 2. 2 minus 1 will be 2 minus 1 will be 1 only. So my answer will be 1 again. And in my stack, what I'll do, I'll push the index again. So I pushed my index, which is 2 basically. So I'll just a second. I'll tell you where I'm doing this thing, where I'm finding the indexes. I'm doing that here in this value. How I'm doing it, I'm checking if just see this thing, I have put two condition here. There are two conditions, that array should not be empty, basically stack should not be empty, and this is another condition. So if this thing explodes, if this thing becomes false, there can be only two conditions: either my stack goes empty or this thing violates. So if my stack goes empty, if my stack, this is a ternary operator, if and else. If my stack goes empty, This means this means that there is no value left in my stack. There is no value. So if no value is left in my stack, what I'll do, I'll just take my answer. I'll take I plus 1 basically, because what will be my I? What will be my I? For example, in this, if I'll pop this, there will be no value left in my stack. So what I'll do, I plus 1, I plus 1 will result me to 1. This one indicates that there is no span basically. No span is kind of, how should I explain this? For example, for 60 and 70, 70 and 60 indexes are 4 and 3. If you'll subtract 4 and 3, you'll get 1. And so what will the value of 60? What will be the value of span? Sorry, value of span will be 1. So that's how this is working. Now, what we'll do, we'll push our value in our stack and we'll push our current value. We are pushing our current value, the value which we have found. One more thing. This thing was very important. What we'll do if we found out the value, basically this thing, how we'll find out our indexes. For example, for the 60, I was standing on my 2 and my next greater left was on my left only, basically on 1. So what I'll do, I'll take the index of this thing. I'll take the index. What is my current index? My current index is 2. I'll take 2. And what is the index of this 80? This 80 is basically my stack top. So I'll just subtract my stack top from this 80, sorry, from this 60, index of 60, which is 2 minus 1. And I'll store my 1 in my answer. You'll get more clarity once we'll move forward. Just give me a second. Okay, so if we are talking about the 70 now, if we are talking about the 70 now, this is a very this is a kind of rare case. How this is a rare case? When you'll check if our element is greater, when you'll check for these value, if you are greater than top, what is currently what's on our top? On our top we have 2. 2 indicates 60 basically. So this 70 will be checked against 60. If it's greater than 60, is it condition true? Yes, this condition is true. So if this condition is true, what we'll do, we'll keep popping it. Just pop it. Just pop the upper value. Which value will pop? We'll pop this 2 from our stack. Now our stack is left with only these two value. We'll pop and what we'll do, we'll move ahead, keeping our counter on 70 only. Will move ahead basically. Now we are comparing this 3 with this 80, and this is not 80 basically, this is an index. So 3 minus 1, what we'll do, we'll check if stack is empty, stack is not empty. Okay, if stack is not empty, then this is the operation we need to do. So currently our I is equals to 3 and our stack top is 1 basically. So what we'll do, 3 minus 1, the answer will be 2. And again, what we'll do, we'll push this index into our array, into our stack basically. We'll push this index. So this is done. Now for 60, we are talking, what will just a second, let me push my this thing. Yep, this is my new stack. Now 60 will ask, this 60 will ask, is my left neighbor greater than me? Yes, it's greater than you. Then just go ahead and find your answer. How would you find your answer? Subtract the current index with the top. So 4 minus 3 will be equals to 1. And what I need to push, I need to push the index of 60 in my stack. So I'll push 4. So my current stack is 4, 3, 1 and 0. Now on 75, 75 again falls into this condition. If you are greater than top, what is top? Top is 4. How you'll calculate? Array of s top. So on 4 we have this value 60. So this 60 is smaller than, basically I'm greater than this 60. I'm greater than this 60. So what I'll do, I'll pop it. I'll pop this 4. Just a second. I'll pop this 4 and I'll keep popping until I find a greater element. Okay, after 75, what I'll do, I'll pop again. Just a second, before popping, what you need to do, once you have popped now, you need to insert this value. Basically you need to insert this value and find your answer. So what you'll do, no, my bad, we'll keep popping until this value find its next greater element. Basically we'll keep popping. For example, 60 will be popped, 70 will be popped, 60 will also be popped. Then we'll come and stay on basically first index. 3 will be popped. The value on 3 in 70. 70 is smaller. It will be also be popped. Value on 1 is 80. So 80 is greater than 75. So our current index is 5. Our 80 index is 1. So 5 minus 1 will be 4. So our stock span will be 4. And what we'll do? We'll push this index into our basically stack. So my current stack is 0 and 5 because this was also popped. And sorry, my current index is, yep, this was not popped, my bad, this was not popped. So my current stack is 0, 1 and 5. What we'll do now, we'll arrive on 6. 6 will check the same thing. These all will be popped, like in our array what we have 5, 1 and 0. So check the value of 5 on 575, it will be popped. Okay, let's pop it. On 1, what is the value? Value is 80. It is, even this is small, so this will be popped. What is the value on 0? The value on 0 is 100. This won't be popped, and we'll find our answer once we have found our greater on left. So answer will be 6 minus 1, because 6 minus 0, my bad, 6 minus 0, because we need to subtract the indexes, this and greater element. So 6 minus 0, the answer will be 6, and we'll again insert this 6 here, and this is our whole answer array. So this will be 1 1 1 2 1 4 6. So that will be our answer. Oof man, this went so long. I didn't plan for this much of content. It's no